Guys, so the next unit that we're going to be viewing is 6.5 chords and arcs. So you guys already know what an arc is. So an arc is basically the outside of the circle. Well, let's go and discuss exactly what a chord is. So right now, looking at the definition of a chord. A chord is a segment. So we know a line segment has two endpoints whose endpoints are on the circle. So basically, if I was to draw a line right here on this circle, if I was to draw a line from here to here, and my two endpoints, so you see this endpoint, we'll call it P, and we'll call this endpoint Q. Both of my endpoints are on the circle. This is known as a chord. So ladies and gentlemen, endpoints that are on the circle, that's going to be known as a chord. Whenever you have a chord, within a circle or in congruent circles, three things are going to happen that's going to help you to actually answer things about chords. So if you look at this first one, if you have two circles, and we know that both of these circles are congruent, there's something that will help you to figure out measurements. So let's do this first thing. So if I have two circles, and they have a congruent central angle. So for instance, if I look at these two angles, and let's go ahead and say hypothetically that this is 40 and this is 40. So right now, both of these circles have congruent central angles. So that means they have congruent chords. So that means automatically, if both of these circles have congruent central angles, then that tells me these two chords are going to be congruent to each other. Okay? Then on top of that, since I can look at both of these circles and see, oh, congruent chords. Right now looking here, both of my chords are going to be congruent to each other. So what that tells me is that since both of those are congruent, then the arcs are going to be congruent to each other. So that means this arc right now, which is this guy right here, and this guy right here, are going to be congruent to each other. And then lastly, since the arcs are congruent to each other, so congruent arcs, and we can already see the central angles are congruent to each other, then congruent arcs have congruent central angles. So basically, these three things are always going to be true whenever everything is congruent. So like for instance, what's going to happen is, if you're not given this, at some point on this problem here, let's say hypothetically on this guy, you're given both of the arcs or both of the chords are congruent. Then when both of the chords are congruent, that means all of these three things are then going to be congruent. So meaning, if they have central angles that are congruent, then the chords are congruent. If they have chords that are congruent, then the arcs are congruent. If they have arcs that are congruent, then it goes back to the central angles. So that means all three of these things are going to be congruent to each other if one of those are congruent. Okay, so for example, let's go ahead and we're going to put into play what we just talked about. So we just said if the central angles are congruent, then that tells you the chords are congruent. If the chords are congruent, then that means the arcs are congruent. If the arcs are congruent, then that means the central angles are congruent. So let's go look at this. So we're given a circle, and it tells you that line OX, so line OX is going to bisect angle AOB. It's going to bisect AOB. So right now, we've already learned the word bisect means cut in half. So that means it's going to cut AOX in half. So what that tells me is that AOX right here is going to end up being congruent to XOB right here. So that means those angles are congruent. So earlier we learned if the central angles are congruent, then the chords are congruent. So if the central angles are congruent, then the chords are congruent. If the chords are congruent, then that means the arcs are going to be congruent. So that means these two arcs are congruent. So what we can conclude here is that angle AOX is going to be congruent to XOB. Line AX, or chord AX, however you want to say it, is going to be congruent to XB. And then arc AX, so arc AX, is going to be congruent to arc XB. Because we know if the central angles are congruent, then the chords are congruent. If the chords are congruent, then the arcs are congruent. And this is going to come into play and help you out whenever you're solving some problems. Chords is the distance, basically how far the chord is, and also the distance from the chord from the center of the circle. So there's going to be one thing, actually two things that kind of coincide with each other, but it's kind of like a reversal here. So let's go and talk about it. So on one here it says, chords that are equidistant from the center are congruent. So for example, if they were to give you an example where you have the center here, and let's go ahead and say from E to F is 4, and let's say from E to G is 4. So right now, chords equidistant from the center. So chord AB is 4 away from the center, and chord CD is 4 away from the center. So since those are 4 away from each other, that means those two chords would be congruent. So that means line AB would be congruent to line CD, just because they're equidistant from the center. And it's also going to work the other way around too. So for example, if we look at 2, it says congruent chords are equidistant from the center. So first we read if they're equidistant from the center, then they're congruent. But if I have two chords that are congruent, so let's say AB, so let's say line AB is going to be equal to 10, and let's go ahead and say line CD would be equal to 10. So since the two chords are going to be congruent to each other, so what that tells me is that the two chords would be equidistant from the center. So it works vice versa. So one more time. If chords are equidistant from the center, then the chords are congruent. If the chords are congruent, then they're equidistant from the center. Okay, so now in this example, we just learned that if chords are equidistant from the center, then the chords are congruent. And also, if the chords are congruent, then they're going to be equidistant from the center. So it works back and forth. So let's go and look at this example. So what we want to try and do is we want to find out what line AB is equal to. So let's go and look at my information here. So if I look at this, I can see that from the center to this chord is 5, and from the center to this chord is 5. So what we learned a while ago, if the chords are equidistant from the center, then that means the two chords are congruent. So right now, this chord Q to S is going to be 7 plus 7, which is 14. So that means since both of these chords are equidistant from the center, that means AB is also going to equal 14. So that means chord AB is going to equal 14. Because those two chords are congruent. Okay, and the last thing that we're going to talk about in 6.5 is about the diameter and its chords and basically how they play into each other. So we're going to learn about 3 things here that's going to help me to answer problems that's going to be given to me here. So let's look at the first one. So if the diameter that is perpendicular to a chord, so remember the diameter goes all the way across the circle. So let's go ahead and say that if I have a diameter, and if it is perpendicular to a chord, so that's what it just told me, then it bisects both the chord and its arcs. So again, if I have a diameter and it's going to be perpendicular to the chord, then automatically it is going to bisect, which means cut in half. It's going to bisect the chord, and it is also going to bisect its arcs. So the two arcs are then going to be congruent to each other because of the diameter being perpendicular to the chord. Okay? And it's also going to work vice versa. So basically, on number 2, if you look here, it tells me if a diameter that bisects a chord, so if I look here and I have a diameter that is bisecting the chord, then backwards, then it would be perpendicular to the chord, meaning it would be a 90-degree angle. So it works backwards and forwards, okay? And then lastly, if you have a perpendicular bisector that contains the center of the circle. So if you have a perpendicular bisector, meaning perpendicular, and it bisects the chord, then it has to contain the center of the circle. So perpendicular bisector, perpendicular, 90-degree angle, it bisects the chord, then that means it has to obtain the center of the circle. Alright, so in this example, we have circle O right here, which is named by its center. And what we can see right now is on what's given to me, O to M is going to be 15. So that means from O to M, this is going to be 15. Okay? And then from P to Q, so that's the entire chord, is going to equal 16. And so right now what I need to do is I need to find the radius. So a while ago I told you guys that if you have a perpendicular bisector, always goes through the center of the circle. So right now, this line right now is technically going to be, if I drew a line all the way through, this would be a diameter going through the center, and it's going to be the perpendicular bisector. So perpendicular and bisector is going to bisect this line, meaning cut it in half. So that means PQ is 16. That means I'm going to cut it in half. So this side would be 8 and this side would be 8. So right now, ladies and gentlemen, if you look at this, I now have a right triangle. So I need to find my hypotenuse. So I'm going to use Pythagorean theorem. So a squared plus b squared equals c squared. So I'm going to do 8 times 8, which is 8 squared. I'm going to do 15 times 15, which is 15 squared. And then I need to find the r value, basically, what's going to happen. So here we go. So with this being said, I'm going to do 8 times 8, which is 64. 15 times 15, which is 225. I'm going to add both of those together, which is going to give me 289. And then to find r, I have to take the square root of both sides. So the square root of 289 is going to give me 17. So that means that r is going to equal 17. So basically what's happening here is the only information that you need to know from this is that this is the perpendicular bisector because it's perpendicular and it goes through the center, so that means it bisects that chord. So that gives me the information then to find the radius, which is going to be your hypotenuse of your right triangle.